Okay, lesson 322, the journey begins. So we're going to start talking about area under the curve and how to kind of look at this. And so this is just the start. This is just, day one of this, but just heading down this path that we're on. So you know how to calculate area of many different shapes, such as rectangles, triangles, polygons, and circles. So what if you need to know the area of an irregular shape or a curve, right? One that maybe can't be broken down into familiar shapes. So in calculus, you're going to learn how to do that, even how to calculate the volume of that. But today's just the start of that journey. So let's start by investigating something maybe a little more familiar. So we have Erin driving from Green Bay to Milwaukee. In the first half hour, she drove through a residential neighborhood at a constant speed of 25 miles an hour. As she entered the on-ramp, she encountered heavy traffic, and she was able to gradually increase her speed at a constant rate. So as the traffic dissipated, she reached 75 miles an hour a quarter of an hour later. She continued driving that speed until she got to her destination. So sketch a neat graph of the situation. Be sure to label and scale your axes. So if we're looking at this, right, and we have our graph, 1 hour, 2 hours. Again, this is time in hours. Okay, so half an hour, let's go 3/4, just so we can scale that, right? And then we said we started off at 25, 50, and then we reached 75. And so this is miles per hour or velocity, right? This is your, this is your velocity. So this graph is a velocity graph. Okay, so we start off at 25 miles an hour, and we do that for a half hour. So what we're talking about is constant for a half hour, and then we jump to 75, but it takes her a quarter of an hour to get there. So we're talking about a constant increase, and then we drove 75 miles an hour the rest of the way, all the way to her 2 hours. So this is kind of what our graph looks like. It says then shade the area between the curves here, between the curves and the x-axis. So we're talking about technically cutting that off there. But for the sake of that, I am actually going to not have that there. Well, I don't want to erase all of it. There we go. So that way we can see how to do this. So what units are you calculating when you calculate the area of the shaded region? So area is length times width, or base times height. So we're talking about the base times the height, right? So we're talking about units here. So we're talking about hours times miles per hour. So if we did that, miles per hour times hours, right? Our hours are actually going to cancel, and we're going to be left with a unit of miles. So we're talking about distance, right? So we're talking about a distance graph. A velocity graph, but when you calculate area, you get the distance, right? So let's actually do this, okay? So let's calculate this area. So let's make this a triangle, because this is kind of hard to see. So we got a triangle here, and then we have two rectangles. So you got your triangle here. So you got this triangle, you got a rectangle, right, and then a big rectangle. So you can see all those there. So let's calculate those areas. So let's start with a small rectangle. So we have a height of 25. We have a base of 0.75 of an hour. Okay, plus we have our triangle. So our triangle next is 1/2 base times height. So our base is 0.25. And our height goes from 25 to 75. So our height is actually 50. Plus, then our big triangle is, our base is 1.25, and our height is 75. Okay, so now, if we add those up, so this is 18.75 plus 6.25 plus 93.75 So So if we add those up, you get 118.75 miles. That's how far she traveled. Okay, so from 0 to 2, that's how far she traveled. And that's the area under the curve. Okay, then it says, what does the area from 0.5 to 0.75 represent in the context of the problem? So we're talking about this area. Okay, and so what are we talking about? We're talking about the distance traveled as she was accelerating. As she accelerated from 25 miles an hour to 75 miles an hour, or the time, or the distance she traveled while she was in, the traffic as it dissipated. So area under the curve here gives you an idea of what this might look like as we move into like a curve. It also gives you some ideas as to notation, right? So the notation there, you can see the A area from A to B, right, of the function f from A to B. Okay, and so we're going to do this for this next one. So the function is 9 minus x squared, and we want to find the area of our f function from 1 to 3. Okay, so let's do that. So if you look here at this next graph, right, we have it says obtain a resource page. I'm just going to draw it here, but so we have an f function of 9 minus 2 to the x, right? And we're doing that from 1 to 3. So let's graph it at 1. So if we have 1 and we plug in 1, right? So we plug in 1 here, right? That would just be 2 to the first. So 9 minus 2 is 7. So we're actually going to have 7. So I'm trying to use my dots there. 7, right? Sorry for this.
Pardon the interruption, Lakeway. Jonathan Graham, please come to the front office. Jonathan Graham, please come to the front office.
If we plug in 2, we're going to get 2 to the second, which is 4. And 9 minus 4 gives us 5. So we're actually here. Okay, and then at 3, if we plug in 3, that's 2 to the third, which is 8. 9 minus 8 is 1. So we're here. So we have this curve that we're looking at, right? And it tells us to calculate area. So again, we're talking about calculating the area here and cutting it off, right? And there's several ways to do this. You could do one big triangle with a rectangle at the bottom, right? You could do 2 small triangles with a rectangle at the bottom. There's several different ways you could look at this. You could do a trapezoids, a lot of different ways. But just for the sake of time, I'm gonna do one big triangle, okay, and then a rectangle at the bottom. So 1/2 base. Our base there is 2, and our height goes from 1 to 7. So our height is 6. Plus our rectangle at the bottom has a base of 2 and a height of 1. So 6 times 2 is 12. Half of that is 6. Plus 2 gives us an area of 8. An area of 8. Okay? And so you can see here, like, there's some missing part, right? Like, there's a little bit of area right here that's missing. That's kind of underneath the curve, right? So we know this is not exact. We're just estimating, approximating right now. But so the next graph, it tells us to add on to the graph. And it says that what we want to do there is actually go from 3 to 6. Sorry, I was trying to figure out 3 to 6 there. So if we start at 3 and we plug that in, right? So 3 minus 2 is 1, square root of 1 is 1. So we're actually in the same spot. Okay? And then as we go here, so 1, 2, 3, 4, 5, and 6. So as we go to 6, 6 minus 2 is 4, square root of 4 is 2. So we're actually going to be here, right? And this is slowly going to curve upward, right? So we're curving upward here, right? The best we can see. Because that's a square root graph, right? And if we calculate that area again, most people would have used a triangle here and then a rectangle at the bottom. And so our rectangular bottom, right, is our base, which is 3 times our height of 1, plus our triangle, 1/2, our base, which is 3, our height of 1. So we have 3 plus 3/2, or 4.5. Okay, and then 104 says, if you let h be the piecewise function, 9 minus 2 to the x, square root of x minus 2, and we go from 1 to 3 and then 3 to 6. Use your work from the previous two problems. So we've already done this. We've already graphed these right together, and we're using that to find our area. So basically all we need to do right now is combine these two. So 8 plus 4.5 gives us an area of 12.5 approximation. Okay? And then 105, the last step of this says, look back at your graph from Aaron's journey. So that would be this graph right here. Right? So we're talking about Aaron's graph. Okay? And they want us to write a piecewise function. So let's just do this. Okay? So we have Aaron's graph with respect to x equals, right? And then we have our piecewise function. Okay? Well, the first part of the graph is easy. That's 25. And it goes from 0 is less than or equal to x, which is less than or equal to 0.5. Okay, and then our third part of the graph is pretty easy too. So we're talking about now this part, right? That's also 75, and it goes from 0.75 less than x less than or equal to 2. The hard part's there, the middle graph, right? So we got to find slope first. So if we take our 2 points, so we have 0.525 and we have 0.7575. Right, and we find the slope. So 75 minus 25 over 0.75 minus 0.5. We get 50 over 0.25, which is actually 200. So we have slope of 200, so 200x, right? And then we're trying to find our y-intercept. So y equals 200x plus b, right? And if we plug a point in, so let's say 25y, 0.5x plus b, we get 25 equals 100 plus b. So b has to be negative 75, so minus 75, and that is from 0.5 less than x less than or equal to 0.75. So that is our piecewise function for Aaron's journey. Okay, and that concludes lesson 3.2.2.